Hey guys, it's Mr. Ing, and we have been struggling through these ionic naming rules, so I figured I'd make you a video. If you know you've been struggling, please rewatch this video over and over again until you figure it out. And for those of you who have been ignoring those worksheets, like those practice problems, it really doesn't help you if you just ignore them. You have to grind through. You have to try to figure out each problem on its own. Let's learn with some fidelity here. And again, I'm really sorry I can't be there with you guys today. I hope this video will suffice. Let's hop right into it. Here, we're learning about our ionic compounds. So name the following ionic compounds. And I organized this so that these first three are easy, and these next two are not so easy. The easy ones have two criteria. Number one, they don't have polyatomic ions. If you look, there's no funky parentheses. See, this thing is a polyatomic ion. It's going to be goofy. Look, here's another one. They make them real goofy. And on top of that, I know that aluminum, potassium, and sodium, they only have one possible charge. Unlike iron, iron has two possible charges, and that complicates the matter for us. But for these three, it's going to be easy peasy. The first one is aluminum oxide. Aluminum oxide. How did I do that so fast? Well, it starts with aluminum, Al. It ends in oxygen, and then you just kind of replace oxygen, the end of oxygen, with an ide. It just becomes aluminum oxide. See, the easy ones are real easy, right? So this just is potassium chloride, right? Potassium chloride, all right? And then I bet you guys can do this last one on your own. Na is sodium, and S is sulfur, so we're going to say sulfide. And done, right? Because it doesn't have any polyatomic ions like these crazy guys, and it doesn't have a weird transition metal with more than one cation. So these become real easy. Let's do the ones that are a little bit more difficult. Here I gave you a list of the ones with polyatomic ions. Look, funky stuff, NO3. You should be able to recognize it as a nitrate, but if you don't, you do have this handy dandy chart that I gave you. So when you see things with parentheses or it has more than one letter, like more than one capitalized letter, then you should use your polyatomic ion chart. So here, NH4 is right here, NH4 plus, right? There's two of them and an O, so this is ammonium oxide. Ammonium, oops, let's capitalize this. Ammonium oxide. Done. All you got to do is check it out inside the chart. This NH4 is an ammonium. And NO3. And NO3 is right here. And when you're just given a name, you don't need to do all the funky math with the charges. We just know that NO3 is a nitrate. So it's K, which is potassium nitrate. Right, so it's just potassium nitrate. I know a lot of you are trying to do this with fidelity and make sure they all cancel out, but you don't have to do all of that. Like just, the people who gave you the formula, they did it right. And then finally Ca, which is calcium, and then NO2. NO2 is right here, nitrite. And I know you're like worried about what about this other two? It just means that there's two nitrites to cancel out one calcium, because calcium's 2 plus, and each nitrite is 1 minus. It takes two of them to cancel out that 2 plus. But you don't have to worry about that. Just the beginning is Ca, which is calcium. And then NO2 minus is a nitrite. So this becomes potassium nitrite. Notice that I didn't need to deal with any of the charges or anything. That's not what we're doing right now. We're just putting it into words, right? Done. The stuff that's a little funky are the ones with Roman numerals. So I was kind of hacking my brain, like if you're unfamiliar with which ones have more than one charge, it becomes a little bit difficult. I had you memorize all of the ones that have more than one charge, but I figured I don't think a lot of you did memorize it. So another easy way to do it is to look at what's called the oxidation states, right? The oxidation states just refers to what are the various cations that you can find. And you know that fancy periodic table that I gave you? That has all the oxidation states, right? But here I have a handy dandy chart that shows that some of them have one oxidation state, nickel, while others have a bunch, right? Look at these guys messing us up with their multiple oxidation states. So let's hop into this. This is iron, and we know that SO4 is a sulfate. If you don't know it, you can look it up in the Ionic, the polyatomic chart that I gave you. But Fe is iron, and iron is right here, and it's got two choices. So we have some math to figure out. So let's put this out. This is SO4 2 minus. How did I get that? I looked it up on the Polyatomic Ions chart. That means this is Fe and something. What's going to cancel out this 2 minus? Oh, 2 plus. Right? It'll be 2 plus this ion here. So I know it's Fe2 plus and SO4 2 minus. They'll come together and cancel each other out. So Fe2 plus is iron, Roman numeral 2, iron 2. And we know that SO4 2 minus is a sulfate. So the name of this compound is iron 2 sulfate. All right. Hope that wasn't too much. Let's try another one. Cobalt is right here. Again, it's got more than one option. It could be either a 3 or a 2. So let's start over here. These are carbonates. CO3 2 minus, CO3 2 minus, CO3 2 minus. I did that because there were 3 carbonates. So I know on this side it's a minus 6 or 6 minus. Right? That means on this side we have 2 cobalts. Right? 2 cobalts. So all of this is 6 minus. All of this needs to be 6 plus. There's 2 of them. So each one needs to be 3 plus. 3 plus, right? That makes this cobalt 3 carbonate. Right? Seems easy enough. And finally, Ni and O, nickel. So let's look up nickel. Oh, look, nickel only has 1, 2 plus. So I don't need to do nothing. I just call this nickel oxide. Right? Pretty good. Another common mistake that I see is like people will put a Roman numeral for nickel. It only has 1. You don't have to do it. Or people see that they see an O and they put like oxalate or they make it all fancy. You know, if it's just one anion, just put the go with oxide. It's pretty easy. Okay, let's finish up. Providing the formula becomes pretty easy. First, you separate them, right? This is a procedure that we did a while back. Potassium, I know, is K+. How do I know? It's an alkali metal. Sulfide is S2-, right? So, remember that crisscross applesauce business? So this becomes K2S, right? Or, if you want to think about it another way, it's going to take 2 of these potassium pluses to cancel out that one sulfide with a 2-. Copper 2 nitrate. So let's separate these suckers out. Copper 2 is Cu2+, right? That's what the 2 refers to. And then the nitrate is NO3-. So 2 plus, 1 minus. It's going to take 2 of these nitrates to cancel that out. So this becomes CuNO3-2, referring to 2 nitrates. Finally, ammonium phosphate. Ammonium is NH4+. Phosphate is PO3. Nope, 4. 3-. So it's going to take 3 of these to cancel out 1 of these. So this becomes NH4, 3, PO4. Ammonium phosphate. I hope that helps. Rewatch it if it helps you. And I will see you soon. Bye-bye.